Alright everyone, this is section 13.2. In this section our goal here is to be able to use general angles that may be measured in radians. So a little bit of vocabulary. An initial side is a fixed ray used to form an angle. Okay, so it's always going to be kind of stationed already on the x-axis, on the positive side. Okay, the terminal side though, that's the one that swings around. Okay, think of like a minute hand on a clock, or the second hand that goes all the way around. Okay, so the terminal side is a ray that is rotated from the initial side to form an angle. So here's our terminal side on this graph here. And in standard position, the position of an angle whose vertex is at the origin and whose initial side lies on the positive x-axis. So this is in standard position. The angle's vertex is on the origin, and the initial side is on the positive side of the x-axis. So we're always going to be working with 0 to 90 to 180 to 270 and all the way back around the 0 again. So it's always looking at kind of like a graph. It's kind of got the same kind of quadrants, but we're just not graphing anything using points or anything like that. So for example here, let's say we want to draw an angle with the given measure here in standard position. So remember, it's got to be at the origin. So here's our dot at the origin. And we have to graph 240 degrees. So this is 0 degrees. Here is 90 degrees. Here's 180 degrees. And here's 270 degrees. And if we go 90 more, that's the same thing as 360 degrees. Okay, so 240 degrees. Well, if I kind of think about that, that's more than 180. So if I think about 240 minus 180, that's equal to 60 more. Okay, so if I go 60 more than 180, it's about, let's say, right in here. That's good enough. Okay, because I had to go all the way here. So this is 240, not 60, 240 degrees. So here's my angle here. Okay, and again, its initial side is on the positive x-axis. It's just kind of laying there. Okay, our next one we're going to do is 500 degrees. So again, think, well, this is 0 / 360 degrees. Here's 90. Here's 180 and 270. So 500 is definitely bigger than 360. So if you think about it, 500 minus one full circle, okay, is 140 degrees. So we're going to have to go to in between 90 and 180, or 140. Okay, but in this case, we had to go all the way around the circle and a little more than 90 again to make 140. Okay, because from here to here, okay, was 140 more. Actually, from here to here was 140 more. But if we went all the way around like that and ended up at 140 degrees, okay, that was actually the 500. So here's our 500 degree in standard position. And again, here's your initial side. So you have to go all the way around and land up at 140 degrees. But what if we want to graph negative 50? Well, we're just going to go the same kind of drawing as regular 50, but go counterclockwise. Okay, so here's 0 again, here's 90, and that was / 360, here's 180, and 270. So if we go basically the opposite direction, here is negative 50 degrees, and what we did was we went counterclockwise the other way, okay? So basically, if you have a negative degree, you go counter, or actually clockwise. What am I saying? Clockwise. That's what we did. We went clockwise to the negative position. But the positive ones, so if you had a positive degree, like the first two we just did, we went counterclockwise. So we went the other way, okay? All right, coterminal, so a little bit more vocab. Coterminal is just two angles that have the same terminal sides where they just coincide with one another. So basically they are two different angles, but they really measure the same thing. And how we're going to find these is we're going to be adding or subtracting multiples of 360 degrees. So that's how we're going to find coterminal angles. So for example here, we're going to find one positive and one negative, so one of each, that are coterminal with negative 45 degrees. Okay, so if we kind of sketch negative 45 degrees, okay, we had to go clockwise since it was negative, okay, and say we want to find that one is positive. Well, we're just going to add 360 degrees to that, so negative 45 plus 360, well, that's just 315, so we can graph that one. So 315, which of course will make us go here, so 315. Then if we want a negative one, we're going to subtract 360 more, and we're going to end up with negative 405 degrees. Okay, so negative 405 degrees, we have to go clockwise to here, so negative 405 degrees. So those are our two coterminal angles, 315 degrees and negative 405 degrees. They're both coterminal, or the same kind of measure, to negative 45 degrees. But let's say we want to do 395 now. Okay, so again, think about, well, this is 0 degrees, 90, 180, and 270. But 0 is the same as 360. Oops. Okay, so again, we got to think of a positive one. So if we do positive 1, well, 395 is still more than 360. So we can figure out 1 really quick by just subtracting that 395 from 360, because we're going to get 35 degrees. And if we graph that, well, we first got to graph that 395 degree angle, which was definitely more than 360. Okay, so if we graph that, and we started off with a 395, that means we made one full rotation and ended up here at 395. But our 35-degree angle, we just went up. So here's 35 degrees. There's our positive one. And now to get a negative one out of that. So our negative one. So we already subtracted one 360 and got still positive. So basically we need to subtract 2 more 360s. So 395 minus 2 360s. And we end up with negative 325 degrees. Okay, so in order to do that one, I have to work in the negative direction. So negative 325 degrees, we have to do clockwise. So here's our one positive and one negative angle. 35 degrees and negative 325 degrees, and they're both coterminal to 395 degrees. All right, a radian is the measure of an angle in the standard position, so it's at the vertex and the initial sides on the positive x-axis, and whose terminal side intercepts an arc of the length r. So it's kind of like a radius r, and it's intercepting an arc basically on a circle. And since the circumference of a circle is 2 pi r, or there are just 2 pi radians in a circle. So when we're working in radians, 360 degrees is the same thing as 2 pi. So in order to convert between degrees and radians, so back and forth like that, say we start in degrees. So I have an angle that's in degrees, and I want to convert it to radians. What I'm going to do is multiply that degree measure by pi over 180, and I'll end up in radians. But the other way, if I start in radians and I want to go back to degrees of an angle, I'm going to multiply the radian measure by 180 over pi, and I'll land back out in degrees. So let's practice a couple of those. Okay, so say I want to convert 125 degrees into radians. Okay, so I'm starting at degrees, but I'm going to radians though. So I had 125 degrees, and say I'll put that over 1. But in order to multiply and get that into radians, I multiply by pi over 180. Okay, so we multiply fractions straight across, numerator with numerator, denominator with denominator. So that's going to be 125 pi all over 180. And that fraction can reduce. Okay, they are both divisible by 5, so that's just 25 pi all over 36. And this is radians. So when it has pi like that, that is a radian measure. So 125 degrees is the same thing as 25 pi over 36 radians. But say in the other one we want to do negative pi over 12 radians to degrees. Well, we're going to do the same thing, negative pi over 12. But in order to get it to degrees, we need to multiply by 180 over pi. Okay, so again, multiply straight across. So I got negative 180 pi over 12 pi. So think of pi like a variable right now. They basically cancel each other out. So we're going to be left with negative 180 over 12. Okay, and that's the same thing as negative 15. And that is in degrees, so I could put my little degree symbol. Okay, so negative pi over 12 is the same thing as negative 15 degrees. So we have that degree and radian measures of special angles. So here I have a full circle, and each degree measure, and it's going by 30, and then the 45, that's 15 more degrees. Okay, and then 45 to 60 is 15 more degrees, but 60 to 90 is 30 more degrees. So increments of 30 and 45, okay? Here we have their special corresponding degree measure, or not degree measure, but radian measure, sorry. So radian measure with them, okay? So they are equivalent degree in radian measures all the way from 0 degrees to 360 degrees, which is the same thing as 0 radians and 2 pi radians. So it's very, very good to memorize these according to this circle here. Okay, and the last thing we're going to talk about is arc length and area of a sector. We have two special formulas to find the length of an arc. Okay, normally we call it S. And then the area of a sector, which is like a piece of pie, if you think about that. It's just the area of that pie shape, okay, in that circle. And it's always in respect to radians, okay? So our angle here is always in radians. Okay? So it's very, very big to note that theta is always going to be in radians because we're talking about sectors and lengths of arcs. So in example 4 here, we have this softball field that forms a sector with the dimensions shown from the length of the outfield fence in the area of the field. So the fence is the arc length. So let's pull up the formula for that. So this is of the fence, and that was r over radius times our theta. Okay. So right now though, we have a degree measure, but we just said, well, theta is always in radian measure. Okay, so let's convert that first. 90 degrees into radians. Okay, and again, multiply straight across. I get 90 pi over 180, which is the same thing as pi over 2. Okay, so now I'm going to start with our S. Okay, and our R here is 180. And we're multiplying it by our radian measure of theta, which was pi over 2 we just got. So again, if you kind of think about it, multiply straight across. So 180 pi all over 2 is the same thing as 90 pi. And if we put 90 pi in the calculator, so 90 times pi, that is about 283, and I think it's feet. Yep, 283 feet is the length of the fence. So here's the length of the fence. Alright. We're still not done though. We need the area of the field. So this is the area of a sector. Okay, so that area of a sector is 1/2 the radius squared times theta, which is in radians, but we already did that already. So we got the area is 1/2 of 180 squared times our theta in radians, which was pi over 2. Okay, so we go ahead and put that in the calculator. So we need 1/2, and then parentheses 180 squared times pi over 2. And if we round that, that is going to be 25,447 feet squared. So it's about 25,447 feet squared, and it's feet squared because we're working in area. So here's the area of the sector of the field, so the area of the infield there.